Energy plays an important role in human life, since almost every activity of them runs with the help of energy itself. Cannot be denied, those large advantages are followed by some big problems too. Problems caused by limited fossil energy are craving from the environmental health issue to the human health issue. Economic growth, industrialization, population growth trigger technology development and also cause increasing in diesel use, and it can affect the air, water, and soil for more pollution problems. Any solutions to renewable energy resources have been called since the limited value of fossil energy became world attention. Energy from biomass has been the center of world attention due to many types of researches about promising renewable energy. The yields are very promising, following the International Energy Agency, who states that in the next 30 years, about 27% of transportation fuels could be fully supplied from the use of biomass and the processing of waste. Agricultural activity plays the same important role in human life, since no human able to make their own food. Besides that, evidently, agricultural waste produced more than the product. In Indonesia, agricultural waste processing not done very properly. In order to overcome the problem, development of pyrolysis into fast pyrolysis can be applied. In its evolution, fast pyrolysis can produce energy in three forms, i.e., crude oil, methane, and charcoal. Therefore, fast pyrolysis produces more bio-oil than methane and car. About 76% of pyrolysis yields is bio-oil, while others are methane and charcoal. Bio-oil is form of energy that very promising in the future because it has high flexibility of transformation path, moving from fossil fuel into green energy. The flexibility is on how diverse upgrading system that can be applied to produce bio-oil. Some methods of bio-oil upgrading can produce abundant energy that can be used for any human activities. Aqueous-based reforming will produce alkane and hydrogen. Hydrotreating will produce gasoline and diesel. Zeolite cracking and esterification will produce upgraded bio-oil for mixed ingredients for other products. Gasification will produce upgraded bio-oil, methane, gasoline, diesel, kerosene, alcohol, and hydrogen. With gasification method, we present you FPRA, Fast Pyrolysis Reactor-Auger development from fast pyrolysis system for agricultural waste processing. This device is composed by the main components of iron, with reactor in the form of an auger to support the output of more bio-oil, around 60 to 75%. When the raw materials in the form of straw and husk enter the device, those materials will be blended by sharp blade until it turns into more subtle biomass. In this channel is applied gravitational motion and particle measurement sensor for monitoring homogeneity biomass particle and record bio-oil yield. Gases are used to heat up the biomass inside the reactor. When the temperature not yet reached the optimal value, which is 600 Celsius, this device will automatically on and the valve will open. Automatically, the blower will turn on for maximum combustion in the reactor. The blue arrow shows gas entering. The green arrow is air pressure from the blower, and the red arrow is heat from unselected component combustion. To support the fast increasing of reactor temperature, heat absorbers with low thermal conductivity is needed. For pyrolysis process, the good stabilizer is polyimide, composite aerogel, and lightweight ceramic. The combustion took place in 4.4 meters reactor, which was channeled with a 13 centimeters diameter pipe. The traditional combustion is also happen to burn another components that can be transported into bio-oil in order to reduce waste, to keep reactor temperature stability, and to minimize the use of gas. After the combustion, the pyrolysis yields, which is biochar, will be accommodated in a container, while the volatile components will evaporate toward pipe and condense it twice to obtain bio-oil, which will be placed in storage tube. Therefore, the uncondensed gas will be placed in gas storage for biogas to save gas fuel for combustion. After turned on, reactor system automatically integrated with temperature sensor for gas valve setting and blower for automatically and measured pyrolysis energy needed. FPRA is a form of service for the farmers to help them optimize agricultural waste processing. With the mobile monitoring pyrolysis method, bio-oil can be obtained right after harvesting. Mobile pyrolysis surely could be helpful for farmers, since the utilization is very practiced to be operated. FPRA could be the right solution for optimizing agricultural yields.